just trying to get this to move off. Okay, this one's nice because it doesn't have, so in a general solution, you have no restrictions. No restrictions here. So this is nice because you don't have to worry about going positive or negative or anything like that. You don't have to worry about those rotations, but you have to make that plus 2 pi k, where k is an element of the integers. So if no restriction is given, you've got to add this to your solutions. Does that make sense? Because this says for everything, k being an integer, integers are positive, negative, so you're either going to add or you're going to subtract. Subtract being in a negative direction, positive being in a positive direction, or adding being a positive direction. So that's all that's saying, is you're going to get coterminal angles at forever and ever and ever to infinity. So if you do not have a restriction, if there's no restriction given, you are expected to do a general solution. No, write that note down somewhere. So if there's no restriction, that automatically indicates you're doing a general solution. And like, if you get the restriction, like yesterday's stuff, you get the restriction, where is it? The restriction right here, like if you get a restriction, then you have to do it on whatever the restriction is. And that will give you 7 answers. So these ones are actually a little bit simpler because we don't have to worry about it. Okay, cosine x equals 1. That side. Okay, so cosine is my x value in the coordinate pair, right? Cosine is the x value in the coordinate pair. So where on my unit circle is cosine positive 1?
1 and 4.
0.
0, yes. Okay, so Xander said cosine is positive in 1 and 4, and Angela, you agreed with him, and you are 100% correct. But because it's that 1, it's actually on the positive x-axis, right? So it's kind of like the barrier between 1 and 4. So you're both right on that one. It only occurs one place. So Kai had said the angle measurement for this is 0 degrees. You guys would agree? So if we were doing it on a restriction, we'd have theta equals 0, and we would have theta equals, where else?
360.
360 or 2 pi. So this one is different. We have nothing indicating whether I should use degrees or radians. So you could use either here, right? Because our restriction told us what we were doing it in. This one doesn't have a restriction, so we could do it in either. But that's the answers for a full rotation, for one positive rotation. There's no restriction on this. So what we would say is 0 plus 2 pi, because 2 pi is my full rotation. K counts how many rotations I do, and then we just define what k is. K is an element of the integers. And again, I will just remind you that in some places, it's written like that, 2k pi. If you're coming from Thompson, or if you've done the grade 12 course before, or you might see it in answers, multiplying, they just did it in a different order. K is always the variable used. I'm okay with that because I'm a Kelly. Z is another letter for integers as well. So both of them are acceptable.
Does it matter if it's capital or okay?
No, it's your rotations. Like how many full rotations are you doing? You could change the letter. You could change it to a P if you wanted to. You just have to define what P is. K is just the one that we always use. Doesn't mean that you have to use it, but I find once we start using different letters, if you really don't understand its purpose, it kind of gets a little muddled. That's all. Yeah, and my K's, look, they range from like lowercase, uppercase, I don't know. I'm a Kelly, they get a little bit wonky. Okay, so again, number of rotations, full rotations. I like to keep my 2 pi together just because that is a full rotation times by however many rotations, and k is an integer. Okay, so this one, same thing, plus 2k pi, where k is an element of the integers. Now, anybody see a redundancy with my answer? It could be 4 pi, yeah. But remember, if it's negative, that would be minus 2 pi. That would put me back at 0. Anybody see the redundancy of this? Isn't this one and this one the exact same thing? Because how many solutions do I have on the unit circle? Just one. It just happens to be 0 and 2 pi. They're at the same place. You will not be marked wrong if you list them as 2, and you will not be marked wrong if you listed them as 1. These are unique situations where your solution is on an axis, okay? We'll talk about those unique solutions. This is like, so these are the same solution, because really, 0 plus 1 full rotation, where are you? You're at 2 pi, right? So this solution is found inside of this one. And if you minus 2 pi from this one, 2 pi minus 2 pi is 0. So the solutions are inside of each other. They're the same thing. It's redundant, but it's not wrong. Do you guys know what redundant means? Like, I say it over and over again. I say it in a different way. I keep pushing the same information at you. I don't need to. Like, okay, Het, you got a 49 in this class. Het, you failed this class. Het, you can't go on to the next level in this class. Like, that's redundant. She's got it. She's got the information that she can't move on, right? Like, me pushing it is redundancy. So it's extra information that means the same thing. It's redundant, but it's not wrong. I like doing it because when we get into these ones, you will have 2 solutions. Because if we looked at this picture, it just has 1 solution. When we go here, where are my 2 solutions? Where's sign positive? 1 and 2.
1 and 2.
I love it. So we have answers there and there. Nope. We have answers here and here. Those are wrong. I was stuck on cosine. Now that kind of looks like eyeballs and rosy cheeks on maybe somebody with a flat mouth. I don't know. No, okay, it's the best I've got, guys. Okay, so my answers are here and here. So I know I have 2 answers. I have 2 unique answers. So what are those answers? Theta equals, what's this one right here? Pi over 6. And the second one? 5 pi over 6. So a couple of things. If this is a denominator of 6, this one will have a denominator of 6 as well. Okay? Because they're both sine of 1/2. I'm thinking sine is y, that's a short and a long. A short y and a long x. So I know those are my 30-degree ones. Again, that's how I remember it. I math it out. Now, again, there's no restriction. We're writing a general solution. It may not say general solution. It may say for all domain values. It may say for XER. Have you guys have seen this before? That means all domain, because X is our domain. You guys would agree that X is the domain. E means element, and R means of the real number. So it just means every possible known number out there, which is negative infinity to positive infinity, which is no restriction, like you're not on a thing. So it might not say general solution, it might say for all domain values, it might say XER, it might give you a domain range of negative infinity to positive infinity. Again, redundant, they all mean the same thing. So here, these are 2 unique values. If I want to get back to this first value, what do I have to do to get a coterminal angle for it? Add 2 pi. And we're going to add 2 pi a bunch of times. Or minus 2 pi. Doesn't really matter. And then this one, same thing. We're going to add the 2 pi. And remember, integers are positive and negative whole numbers. You won't get a coterminal angle if k was like a half of a rotation. You wouldn't end up back where you started. So it has to be an integer. Integers are positive and negative whole numbers. So you're going in a positive direction or you're going in a negative direction. That is your general solution here. And you need the two. These are not the same. Okay? So if you started here and you added 2 pi, you're going to end up right back here. You're not going to end up here. And you're like, well, what if I added 90? If I added 90, would that get me there? Right. So that wouldn't get me there. So, like, it has to be two unique solutions. All right, let's do this one. Okay, we got to isolate the secant first. So I want to get secant by itself. So divide by 2, exactly. So secant x equals 3. What reciprocal function is secant? Okay, good, because I didn't know how I was grammatically going to finish that sentence. Thanks. I was like, what is secant? It was bad. So cos x of 1 over 3. Is this on the unit circle? No. Maybe. It's not, because what are our things on the unit circle are 1/2 root 3 over 2 root 2 over 2. Oh, I wrote those, so you got. So any of those I'm good with because they're exact values. 1/3 is not in that group, so right away I know that's not an exact value. So that means I got to use my calculator. Right, so I'm like, okay, I need to know my rules. Okay, so this is like the stuff we did yesterday. Where is cosine positive? Quadrants 1 and 4, right? We're good with that? So we're going to solve for quadrant 1 first. Do you guys want to do this in degrees for this one? Okay, we got to change our calculators. Well, I have to change my calculator. I don't know about you guys. So we're just going to change this to degrees. And why? That is just, let's live on the wild side. Okay, so we're going to do degrees this time. So I'm going to go. Pardon?
Is 1 over 3 in radians?
No, angle measurements are in radians or degrees. We're calculating, that's the angle, right? So x is the angle. So 1/3 isn't an angle measurement, so it doesn't have any units attached to it. So we're making the decision to solve for the angle using degrees this time, just because we've been using radians all the way along. And this one's in the calculator, so it's not nice, so might as well do this one in degrees. So it's your angle measurement that has the units of measure, not the 1/3. So second function, cos, 1 divided by 3. And so x is equal to 70.5. We'll go 2 decimal places. We'll live on the edge. All right, that's pretty exciting. That's my first one. So I got an angle right here. I'm going to have an angle somewhere down here. Everybody good with that? It's pretty exciting. That's a terrible circle I just drew. I have to draw the circle first, then put the dots on it, is what I've learned. Okay, so now to find the answer in quadrant 4, what am I going to do? We're going to do our rules. So this one is 360, so theta is equal to 360 minus theta reference. Remembering that the answer from quadrant 1 is theta reference. So 289.47 degrees. And that does land, you guys all would agree, that does land in quadrant 4? Right, so we know if we've done it correctly because our angles are telling us if we've done it correctly. Now, there is no restriction on this, so we need to do a general solution. Right, no restriction, so we still need to do a general solution. That's the answers if I was doing one full rotation, but there's no restriction on this, so I have to add in the infinite possibilities of answers. So I'm adding a full rotation, but we're in degrees this time, so what are we adding? 360. So 360 degree K, where K is an element of the integers.
If you just draw a normal looking E, it's still fine, right?
Yeah, I won't judge you, but,
Okay.
okay, maybe I'll judge you a little. You know me.
Yes, but is it like Mark's judging or just?
No, it's just personal judging, don't worry.
I can live with it.
Okay, you can live with my personal judgments, not a mark judgment, fair. The E element in math is like a letter, a backward C or it's a forward C with just a line through it like that. That indicates that it's like the element of, I think it is, no, it's not I was going to say it's a Greek letter, but it's not. Because the E is more like our regular E. So there you go. We use a lot of the Greek letters for funsies. So yeah, and in real numbers, you know when I did this one's not right either. This is the fancy, so E, and I never do my R correctly. There's 2 lines in the R for real numbers. There you go. I'm looking at my Greek letters and there's no R's in there. But that indicates real, like in my equation editors, if I want to use XER, that's the R that gets inserted. That's the proper notation. It's just not in other typing things. So that's it. That's really so that's it with a calculator, without a calculator, in radians, in degrees. I feel way more comfortable on the unit circle because I know what the answer should be, but that's just me. I'm going to stop this video.